So in this video we are going to build a low pass filter using Simulink. So I have written a small notes for what are the values for resistor and capacitor to choose, and I have derived what is the output equation here. So let's see. So I need to take a resistor of 4.7 kilo ohm and capacitor of 47 nanofarad. Okay, and we need to calculate the cutoff frequency. So the cutoff frequency is 1 by 2 pi fc, sorry, 2 pi rc, and if you substitute both r and c values in this, we get our cutoff frequency as 720 hertz. So for the low pass filter, if cutoff frequency is 720 hertz, what does that mean? It will not allow any frequency higher than 720 hertz, right? Okay, this is the one thing. So in my example, I want to take noise signal as amplitude of 1 and frequency is 1000, and my original signal is amplitude 15 and frequency 100. So our low pass filter should only allow this second signal and eliminate the noise signal. And we know that for low pass filter we take output across the capacitor. So from Kirchhoff voltage law, V in equal to V out plus IR. So V out is voltage across capacitor, that is equal to Vn minus IR. But what is the value of I? I is equal to C into dV out by dt. I mean I equal to C into dVc by dt. But voltage across capacitor is similar as output voltage. So this is my output voltage. So based on this only I am going to construct the diagram based on this output equation. And here we can note that whenever I multiplied R and C, I got the value as 0.00022. Okay, and this is the gain which is multiplied to this derivative, output derivative. Okay, so remember these 2 points and let's construct the low pass filter. So first, as I said earlier, I need to take two signals. Okay, let me take the sine wave. Okay, and let's assign some values to this. Amplitude is okay 1, and let's give this frequency as 1000. So this is above cutoff frequency, so our low pass filter should not allow this. Press OK. Then now choose another sine wave. Okay, to choose this wave, you click the left side of mouse 2 times. You will get the search option, and this one should be amplitude. What we have assumed, amplitude 15 and frequency 100. Okay, let's take amplitude 15 and frequency 100. So we should get output this one whenever these two signals are mixed. Press OK. Okay, we are done with this. Now we need to add these two signals. For that I am taking adder. Okay, so this is the adder, and let's pass these two signals to the adder. Okay, I passed two signals. Now after passing this input need to send to a low pass filter. So I will build a low pass filter in separate subsystem, because it will be confusing if everything has been written on a single plane. So in a particular hierarchy we can build the subsystem. So let me give this input to the subsystem. The adder output should be given as input to the subsystem. Okay, now to observe the output of this, actually I am going to build a low pass filter in the subsystem. The output is observed across the scope. Okay, so first build the subsystem here. Okay, so from the formulas what we need to do is, this is our output, output is V in. Okay, input is addition of the two signals, so which we are getting from this port in 1. Okay, and we should subtract it from RC dV out by dt. For that I need to select a subtractor here. Okay, choose a subtractor, and what are the input to the subtractor? The first input is V in minus RC dV out by dt. So RC is the gain, the output is taken here, so let's take a gain here. Okay, so what is our gain value? It's 0. Okay, I am copying this. This is the gain. Press OK. Okay, and I got gain, and there should be a derivative, right? This derivative is multiplied by this gain. So let's take a derivative, discrete derivative. Okay, so I have taken derivative, and let's give this output to the derivative. So the output of this will be dV out by dt. Okay, and this dV out by dt should be multiplied with the gain which is there, that is RC. Okay, just supply to it, and so now here we will get output as dV out by dt into RC. That should be given as another input to the subtractor. Okay, this is the diagram. We are done with the subsystem. This is the low pass filter. Now get back to the original subsystem. So we will get output, and we need to observe that across a scope. Okay, click on scope here. Alright, and okay, let me first take two other ports to this. Okay, there are 3 ports to the scope, and the first thing we need to observe is the signal 1. Okay, let's observe signal 1, and second thing need to observe is the signal 2. Okay, and third one is the output across the low pass filter. Okay, so I think we are done with the constructing of the low pass filter. Now just save this and run. Okay, now after running, you need to observe the whatever the thing that has simulated in the scope. Double click on scope. Okay, so this is the output which I got in the scope. So let's change the view format. Click on layout, and I need to observe 3 as the, so my view has been changed now. Now let's drag this output. Okay, and this is our noise signal which has frequency of 1000 Hertz, and you can see the amplitude of, generally the noise amplitude will be very less. Okay, it will be in the like very little amplitude, so that I have chosen here amplitude as 1, and this is the signal with 100 Hertz. Okay, I think I have chosen 100 Hertz. Let's see me again. This is with 15 amplitude and 100 Hertz. Okay, 15 amplitude is there and 100 Hertz signal, but the third column is output. You can see the output is exactly same as the second, which is having the low frequency.